Okay, welcome back to the next part of the video. This is another Orbiter 2010 video, an installment in my Absolute Beginner Guide. And this is a video series that has a special emphasis on people who are brand new to Orbiter. You've downloaded the program, you've got it installed, it works. You load it up, but you really don't know how to do anything with it. This video series is put together to help people learn how to do things like rendezvous with the space station, get to the moon, and just work with Orbiter in general. Now, I'm assuming that you're going to watch these videos in order, so if you're coming onto this video and it's the very first one that you've seen, go ahead and stop the video, go back to the Absolute Beginner Guide Part 1, and work your way forward. Now, having said all that, let's go ahead and jump back into this video where we took off from Cape Canaveral, we got into orbit around the Earth, and we're heading out to the moon. In the last video, we actually experienced a problem, an unforeseen problem, and that problem arose from having one of the realism settings turned on, and I forgot that I had it on from one of my other flights that I had done. And it turns out that it kind of screwed up our flight, but that's okay, because it's something that I think absolute beginners should understand is that things don't always go exactly like you want them to go. And you need to know that if you experience a problem, that you can recover from that problem. You don't have to just abort the flight and start over from the beginning. In almost all cases, you can fix the flight. And that's what we did in the previous video. So let's go ahead and pick back up here and start heading back, start our plan over for going to the moon. Now, in the last video, we kind of talked about, setting up transfer MFD, but we'll go ahead and do that again. Reference is Earth, target is moon, and we're going to press HTO to turn on hypothetical transfer orbit. Now, that's step 1 is turning on HTO. Step 2 is to press DV plus and hold it until your ellipse is far out enough that it intersects with the moon. And we've already done that in the previous video a couple of times, so we won't do it again here. But just as a reminder, as you're pressing DV plus and holding it, you'll notice that this ellipse doesn't quite reach the distance to the moon, and here it says no intersection. So I press DV plus again, one more time, one more time, one more time, again, one more time, and this next time probably, now the no intersection goes away, and we now have an intersection with the moon. Once I get to this point, I like to press DV plus at least 10 more times, maybe even 12. And the reason for that is because just because we now have an intersection with the moon, you'll notice that our orbit is just barely touching the distance out to the moon. So we'll get there, but we'll basically be coming up somewhat short. You might think, how can we be coming up short if it says the intersection is complete? Well, it's not necessarily that we're coming up short, but we're basically on a ballistic trajectory with the moon, where our velocity is going out, and it's just barely touching the altitude of the moon. So if we were to use that plan, which we could, we would be on a ballistic trajectory straight with the center of the moon. And what we would prefer to do is get out to the moon and be on a trajectory that'll take us, out to the side of the moon, because we don't want to crash into the middle of the moon. We want to get into orbit around the moon. So once it says the intersection is there, I press DV just out of habit at least 10 times, maybe even 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's just go with 11 this time. Last time we did 10, this time we'll do 11. So step 1, HTO. Step 2, DV plus. Step 3 is either EJ minus or EJ plus. And what we're looking for is when the gray line is laying over top of the dashed yellow or dashed orange line. And again, the dashed orange line is what where transfer MFD thinks the moon will be when we get out to that point. Currently the moon's here. The solid line shows where the moon's at right now, and the dashed line shows where the moon will be. And this gray line needs to lay over top of it, so that that's where we are going to be. So we'll lay that right there. And you'll notice if you go plus a little bit, it's a little bit farther past, and sometimes if you go minus a little bit, it's a little bit off. There isn't quite enough precision here to always get this to lay straight over top the middle. That's okay. It doesn't really have to be that accurate, because we're only talking about a difference the difference of burning between 2 seconds or sooner or 2 seconds later. So it isn't going to make that much difference. So if you have it here, that's okay. If you have it here, that's okay. But really, if you can get it sort of more lined up, that's the best. Now we want to warp time forward until we are at the time to do the burn. And the time to do the burn is given to us here, the DTE, and off the top of my head I don't know what that acronym stands for, I'd have to look it up. But we can also see here in Transfer MFD that our orbit around the Earth, here is Earth in the middle, is moving forward. So we're just going to press T a couple times to move time forward. Notice the DTE is counting down, and we're getting closer to this point over here, and this is when we're going to do the burn, is when this line is over here. As we get close to this point, as always, we will come back to real time so that we don't overshoot, and so we can give the autopilot time to settle. So when you get down to, say, 200, about right there, about 125 seconds will be good. Go ahead and go to the prograde position by pressing the prograde autopilot. Give the prograde autopilot time to settle. Now, we don't actually start the burn when DTE is 0, and the only reason for that is, according to the Orbiter PDF and the various instructions that I've seen, we actually want to start the burn when the DTE is about 30 or 40 seconds, and again, it doesn't have to be exact. Different guides will actually give you different time frames for starting it, but basically when it's about 30 seconds. And I don't actually, personally, I don't know off the top of my head why that is, why you don't wait for it to be 0. I think it has to do with balance. You always want to balance your burns. So you start the burn a little bit early before you get to the actual, because ideally you would put in 3,138 meters per second worth of velocity in no time, in like 0.01 second. You would put in all that velocity right here, but since we can't do that, we need time to accelerate to that point. So I think that's why we start the burn a little bit early. So when this is about, and it could even be 45 seconds, but 30 to 40 seconds, somewhere in that time frame, we'll go 40. Pressing the plus key and holding it, tap the control key to lock it. We're now doing the burn, and the one thing that we need to do is when the DTE gets to 0, we want to turn off the prograde autopilot. The reason we do that is because the prograde autopilot will continually adjust the vessel around the curvature of the Earth in order to keep it into the prograde position. And we don't actually want to do that once we get to the once DTE is 0. And this has to do with the semi-major difference, which isn't shown in this MFD. So as we get here to 0, turn off the prograde autopilot, and now the vessel will just it'll yaw naturally on its own, and it's fine to let it do that. What we can do now is we can even warp time forward to get through this burn a little bit faster. You want to be very careful with this. Don't go more than 10. But we're going to burn until the DV is 0, and you'll notice that it's counting down, 2.055 and so on. So if I press T1 time, I can get away with the time warp. For absolute beginners, I would probably recommend that when you get down to maybe 500 seconds, like now, go ahead and come back to real time and let the burn handle itself in real time from this point forward. You'll notice the ellipse here is growing out to that point, and it will continue to grow until it's all the way overlapping the hypothetical. As we get down to DV about 100, we're going to want to press Control and start subtracting some of the delta velocity like I'm doing now. You can notice my main engines are coming down, and if we don't do that, we'll end up overshooting by a lot. So now I've got just a little bit of main engine. I'm reducing the engine some more. Going to reduce the engine some more. Get ready to press the asterisk key. Kill the engines.
Rotation.
Now with just a little bit of translation, I can translate that last little bit of delta V. So when I'm at 0.00, like that. And if for any reason you overshoot it one way or the other, you can press Control 9, for example, or Control 6 and just get it corrected there so that it's basically 0.00 is what you want. Now we are on our way to the moon. So what we can do here, we're basically done with this MFD, but we can turn off HTO, that's hypothetical transfer orbit. We can turn that off. If we want, we can keep this MFD open. Again, we don't really need it. Now all we have to do is warp time forward to get out most of the way to the moon. And I say most of the way because we're not going to go all the way to the moon because we have a mid-course correction to make. So if we press F1, we can look outside. Look at the pretty view here. We left Earth at daytime. Convenient coincidence. And we'll press T, just maybe go to 100, 10 or 100. You don't really want to do too much time warp when you're in closer to the planets, especially if they're in view like this. Because when the planets are in view, these textures are, being rendered on your video card, and it can cause frame lag and all kinds of other issues. Of course, that depends on your computer. My computer's pretty good, so I don't experience too many of those problems. But generally, just warp time forward at 10 or 100 until you're out away from the planet a little bit. And as you get farther away from the planet, the textures it uses lower resolution textures, so you won't have as many problems rendering. And we can hit kill rotate to keep the vessel from yawing around. I'm going to go out to 1,000 at this point. Again, if we look back at the planet, see what's going on. And there the textures just went to a lower resolution, I could tell. Now we're going to warp time forward until we are quite a ways away. One thing that's interesting to note, and this will be something that I'll mention for the first time, this G meter down here is the gravitational influence of the source or of the reference body. In this case, the reference body is Earth. And according to this MFD, the amount of gravitational influence that we have from the reference body is currently 0.87. As we get farther away from the planet, this number goes down. This is one of Kepler's laws, the inverse square law. As you get farther away from a reference body, the gravitational influence is cut in half, and it's like a reverse exponential, or squared, I think. I forget off the top of my head. But when you get to 0.50, this number will go from green to red, and that's just indicating that the reference body is now a weak reference. Notice now it's red, and we're still getting influence from the Earth, but the Earth is now a weak source of gravitational influence. The dominating influence is now the Sun, and that's why the orbit the orbit HUD updated, and it says orbit Sun now instead of orbit Earth, because now the Sun is the most dominating source of gravity.
Rotation.
Let's go ahead and rotate just for kicks, so that we can see the moon, so we can see where we're going. That's the Earth, so let's go the other way. And I saw the moon coming into view. And there's the moon. Now what we're going to do is we're just going to warp time forward until the moon becomes the dominating source of gravity. And there's a couple of indicators for that. Notice I'm only at warp factor 100 at the moment. That's mainly because I just want to explain things. We can watch the gravitational influence of Earth as it gets lower, but what we really want to do is reference the moon at this point. So in Orbit MFD, let's go to Reference, Earth, Moon, hit Enter, and we can see that our gravitational influence of the moon is only 0.02. So we're going to go ahead and warp time forward until we get much closer to the moon. And it will also automatically update on the HUD. This will change from orbit Sun to orbit Moon once we're close enough to the moon for the moon to become the dominating source of gravity. But that won't happen until we're quite close. So we can continue to warp time forward. Just want to watch your time warps, because it seems like things are happening slowly when you're at 10,000, but as you get closer and closer, things happen faster and faster. So let's go back to 1,000 so we don't overshoot. And once this will automatically update, it'll say orbit moon here in a moment. And that'll just indicate that the moon is the strongest source of gravity. There it is. So let's go ahead and go back to real time. Now let's look at our current situation. And really, this MFD serves no purpose at this point, so let's not even look at it. Let's bring up map MFD, and let's reference the moon, which we already are referenced. So let's target Brighton Beach. And let's set our display lines to orbit plane. And let's understand what's happening. Currently, if we were to just go to the moon from our current location and get into orbit around the moon, we would have a problem where this would be our orbital plane around the moon. It would be almost equatorial. And you can see Brighton Beach is way up here, so it's several thousand kilometers away from the equator. So if we were to go to the moon and get into orbit around the moon, we would have a huge plane change maneuver to make. And remember, plane change equals expensive, especially when you're in a tight orbit around a body. That plane changes are very expensive. This is one of the reasons why it's actually beneficial to do an off-plane transfer to get out to the moon, because by the time you arrive at the moon, your inclination is much steeper. So instead of having an equatorial orbit around the moon, you'll have a much steeper inclination. So your orbit plane around the moon it'd be more of a wave. But we're not obviously covering off-plane transfers in this video, but I just wanted to mention that. So what we need to do here, while we're still quite a ways out from the moon, we're still 23,000 seconds away from periapsis, which is was that about a quarter of a day, so what, 6 hours or something like that, away from periapsis. What we can do is we can take care of our plane alignment now, and it's very cheap to do it while we're still this far out away from the moon. Right now I'm just kind of rolling so that I'm heads up toward the moon, as referenced here. You can see these. I forgot I was at 0.1. So I'm now heads up to the moon. The indicators here are all, upwards. So I need to adjust my orbital plane so that it crosses over top of Brighton Beach, and I can do that by either going to orbit plus or orbit minus. Now, unfortunately, off the top of my head, I don't know if I need to go orbit plus or orbit minus. There is a way to know. I'm currently on a retrograde inclination toward the moon. I can tell that because my inclination is 172, so that means I'm actually going backwards around the moon. And that's fine because the moon doesn't have any atmosphere to speak of. There's a few dust particles, but other than that, there's no atmosphere to concern myself with. So instead of an inclination that's closer to 0, which would be coming out of the west and going east, which is a normal inclination, my inclination's backwards. So that means my orbit plus and orbit minus are backwards. But having said that, I still can't think off the top of my head which way I need to be oriented. So what I do in this case is I'll just go orbit plus and let the autopilot get settled. And I'm just going to do a small engine burn to see which way the orbit plane changes. And this happens to be the correct direction. Notice that this orbit plane is getting closer to Brighton Beach, so that means I can put in a little bit more main engine. And notice that the autopilot isn't holding onto this position, so I don't really want to use the full power of the main engines because it would affect other attributes of my orbit. You can see here the PEA is quite a bit off. So what you could actually do here, this is preferable, turn off the autopilot, and as this is changing, I could actually just pitch a little bit to keep myself closer to this 90-degree position. That way it won't affect my PEA so much. So I'm just putting in a little bit of engine burn, and notice it's having a nice, quick effect on the orbit plane. It's getting the orbit plane closer to Brighton Beach. And I'm actually a little bit beyond this point here, but I'm okay with that because it's bringing my PEA down, and and I actually want to bring the PEA down, so I'm okay with that. I just don't want it to go up anymore. because obviously 2,500 kilometers is a very high altitude. We don't need to be anywhere near that high. So just doing a small engine burn. We do a little bit more pitch correction here, just to keep up with this. That's why I don't have the autopilot enabled, so I can keep up with the changes that are happening. And we almost have the orbit plane set. And notice we're using very little engine at this point. This is why we do the maneuver out here, because it's much cheaper. And as we get close to the center of Brighton Beach, maybe about here, I'm going to go ahead and kill the main engines. And the reason that I kill the main engines prior to getting straight over the center is because as I move forward, get closer to the moon, this orbit plane is going to continue to change a little bit. And I generally find that it changes toward Brighton Beach. So if I bring the orbit plane, if I zoom in here, if I bring the orbit plane all the way over to the center of Brighton Beach, then by the time I get into orbit around the moon, the orbit plane will have moved out to here. But if I stop it a little bit short, then the orbit plane will continue to adjust forward as I get closer to the moon. This may be a little bit too far down, though. Let me bring it up a little bit more. And we'll go with that. That's probably good enough. Okay, so our situation now is that we are on track for the moon, and we are on track for Brighton Beach. But we still have one concern, and that is that our altitude at periapsis is very, very high, relatively speaking. We're at 2,500 kilometers, and when we get to the moon, we really want our altitude around the moon to be much closer to the surface. The highest peak on the moon is about 11 kilometers. It's actually 10.8 something. You can look it up on Wikipedia if you're interested. So to be realistic, we would like our altitude at the moon to be like 13 to 15 kilometers. Practically speaking, for the sake of orbiter, there is no terrain on these bodies, so you could bring your periapsis all the way down to 500 meters for that matter, and you're not going to crash into anything on the moon. But to keep things a little bit more realistic, I would like to bring the PEA to the point where we have a more realistic altitude, like 15 kilometers. So let's go to prograde position just to take a look at the moon, see where we're headed. Now, there is a problem with orbit MFD in terms of its accuracy. When you're still this far out from a body, the gravitational influence being 0.41, this MFD, this information isn't very reliable. We have to be down to like at least 0.8 and preferably 0.9 before the PEA really starts to become reliable. So as we make adjustments here to the periapsis, we're going to be taking into account the fact that this isn't really accurate. But we have enough of an adjustment to make that we do need to make some kind of a change. Now, in order to bring the periapsis down, what we want to do, we don't want to do a retrograde burn like we talked about in raising and lowering the orbit. And that's because we're on a hyperbolic trajectory around the moon. In other words, we're going to get to this point and then we're just going to keep going. We're not in orbit around the moon. We're just going to swing right by it. So it turns out that it's a lot more efficient if we do something that's a concept that's called an inward burn or an outward burn. And I'll explain what those are since we haven't talked about that yet. We've talked about facing prograde to do a burn. We've talked about facing retrograde to do a burn. We've talked about facing orbit plus to do a burn. We've talked about facing orbit minus to do a burn. There's another direction of flight that we can do, which instead of being forward or backwards or up and down, would be left and right. Of course, that might be backwards on the webcam, but basically pointing that way or pointing that way. That's called inward and outward. Now, let's rotate so that we are minus 90 degrees. So we're going to be at a right angle to the moon. Actually, yeah, let's go this way. And we know that we're at minus 90 when we get to 270 because 360 minus 90 is 270. So I'm just yawing over to that point. Okay, and let's look at this from the external camera so we can see what we're talking about. So our direction of flight to the moon is basically this way. You know, we're going forward, and we're now currently facing to a right angle to the moon, to the minus direction. This is inward. We're facing in toward the orbit. If you think about the orbit here, we're facing, instead of facing toward the orbital path, which would be this way, 0 degrees, we're facing inward. We're facing a right angle to that direction. So that's inward. Let's talk about outward. Well, outward is the opposite. And it would just be the spacecraft facing 180 degrees opposite from its current direction. Let's go ahead and show what that looks like. So now we're facing outward. So our direction of flight is this way, still hasn't changed. But instead of facing in toward the orbit, we're now facing out away from the orbit. Now, if we needed to raise our periapsis, if for some reason, let's say our trajectory to the moon had us on a crash course, and that would be the case if you were to have your intersect set and you didn't add any additional dV, you would be on a crash course with the moon. If we were on a crash course with the moon and needed to raise our periapsis, we would do that by facing outward. Currently, I am facing outward, and if I put in a little bit of engine velocity, you can see the PEA is going up. It's getting higher. That's not what I want, so I'm going to kill it right away. What I want to do is I want to face inward. I want to be the other direction. So instead of being prograde, which is here, I want to be inward, which is minus 90 or 270. So this position here, and again, let's look at that from the external camera so we can understand. We're facing inward toward the orbit. Now, by facing inward and applying main engine, I'm going to bring my periapsis down very quickly. So I'm just going to press plus, or rather press Control key and hold it, press plus a couple times, and you'll notice that as I'm doing this, the exact direction of flight's changing a little bit.
Translation, rotation.
So in order to make this the most efficient burn possible, I kind of want to keep up with that change. And you don't have to do this, but I'm just yawing the vessel to keep up with the change in orientation. I'm going to bring the PEA down quite a bit. I don't want to bring it all the way down to 15 kilometers because as I continue to move forward and get closer to the moon, the PEA is going to change, and that's because the orbit MFD is not accurate enough at this point. So let's bring the PEA down to I'm just going to guess. I don't even know. I'm just going to say 150 kilometers. I overshot it, but that's fine. Now I'm going to just press T one time, 10x, and just watch what happens with the PEA. Okay, let's go to 100 even. You can see that as I'm moving forward toward the moon, the PEA is continuing to count down. So that means if I had set it at 15 kilometers, by the time I move all the way forward to get to the moon, then I'm going to be well below 15 kilometers. And if my target is 15 kilometers, then that's not what I want. So I'm just going to watch the PEA just to kind of get an idea of how quickly it's counting down. Now there are other MFDs you can use that are that have the precision that's necessary so that you don't have to do these kinds of guessing games. But for the sake of the absolute beginner, I think it's actually good to know how to do this all the same. And I think it's also maybe a little bit easier because you don't have to download additional MFDs. So as I'm moving forward closer to the Earth, I can see this is counting down, but it's not counting down really fast. So I'm going to go ahead and go back to real time, and I'm going to bring the PEA down a little bit farther because, again, my target's 15 kilometers. So I'm going to bring it down to, let's go with 60. Actually, I accidentally tapped the plus key and did a full blast of main engines and brought it all the way down to 43, but that's okay. Because as we get closer and closer to the moon, this gravitational number gets closer to 0.80, and the closer it gets to 0.8, and the closer that it gets to that, the more accurate this becomes. And by the time we're at 0.85 or 0.9, this number will be very accurate. So I'm just going to go ahead and warp time forward until we're at that point, and then we'll end this part of the video for the sake of time. Still counting down, but you can see it's pretty accurate at this point. Now we're only counting down just a few meters per second. So let's go to real time. And now that we're at 0.89, we'll go ahead and we'll do just the last little bit of correction. We can probably even use translation for this. That's a little slow. So let's press the plus key, or Control plus, and just bring the PEA down to 16 kilometers. And that way, any difference between here and here should be right there. We have it. Okay, so we are on target with Brighton Beach. We have our periapsis down to the point that we need. So we'll go ahead and end this part of the video here and pick up in the next part. If you like this video, go ahead and hit the like button, please. Subscribe to the channel if you like the content. I also have a Facebook page where I post all my orbiter videos, put up some additional pictures and space-related content from time to time, so please check that out as well. And I will see you in the next part. Okay, welcome back to the next part of the video. This is another Orbiter 2010 video, an installment in my Absolute Beginner Guide. And this is a video series that has a special emphasis on people who are brand new to Orbiter. You've downloaded the program, you've got it installed, it works. You load it up, but you really don't know how to do anything with it. This video series is put together to help people learn how to do things like rendezvous with the space station, get to the moon, and just work with Orbiter in general. Now, I'm assuming that you're going to watch these videos in order, so if you're coming onto this video, and it's the we kind of talked about, setting up transfer MFD, but we'll go ahead and do that again. Reference is Earth, target is Moon, and we're going to press HTO to turn on hypothetical transfer orbit. Now that's step 1 is turning on HTO. Step 2 is to press DV plus and hold it until your ellipse is far out enough that it intersects with the moon. And we've already done that in the previous video a couple of times, so we won't do it again here. But just as a reminder, as you're pressing DV plus and holding it, you'll notice that this ellipse doesn't quite reach the distance to the moon. That it kind of screwed up our flight, but that's okay, because it's something that I think absolute beginners should understand, is that things don't always go exactly like you want them to go. And you need to know that if you experience a problem, that you can recover from that problem. You don't have to just abort the flight and start over from the beginning. In almost all cases, you can fix the flight. And that's what we did in the previous video. So let's go ahead and pick back up here and start heading back, start our plan over for going to the moon. Now in the last video, and here it says no intersection. So I press DV plus again, one more time, one more time, one more time, again, one more time, and this next time probably, now the no intersection goes away, and we now have an intersection with the moon. Once I get to this point, I like to press DV plus at least 10 more times, maybe even 12. And the reason for that is because just because we now have an intersection with the moon, you'll notice that our orbit is just barely touching the distance out to the moon. So we'll get there, but we'll basically be coming up very first one that you've seen. Go ahead and stop the video, go back to the Absolute Beginner Guide Part 1, and work your way forward. Now, having said all that, let's go ahead and jump back into this video where we took off from Cape Canaveral. We got into orbit around the Earth, and we're heading out to the moon. In the last video, we actually experienced a problem, an unforeseen problem, and that problem arose from having one of the realism settings turned on, and I forgot that I had it on from one of my other flights that I had done. And it turns out